This is Khuzestan, the most arid and desolate region of southwestern Iran. The scene is set under the blazing sun, on the arid desert which stretches away to the wind-swept horizons. The leading role is played by thirst. Thirst which parches the earth, men and animals. Life is conditioned by water. By the continual search for a few blades of grass in order to survive. This is the way it has been since ancient times. Since the first Indo-European tribes built irrigation works, civilization has been dependent upon water. First the Elamites and after them the Sumerians built their cities and temples like this ziggurat at Chogadzambil near the rivers. Archaeological discoveries have shown how, in the elaborate hierarchy of the Sumerian religion, the cult of the sky and that of water had very important places. These remains at Susa, one of the greatest religious centers, are an example. The ancient Iranian civilization reached its maximum expansion in the reigns of Cyrus, Darius, and Ceres. Today the children play among the ruins of the summer palace Darius built, and all unknowing tell each other the sad story of time. The first civilization learned how to make use of water and how not to be its slave. But it was the Romans who came later who made a vast net of roads with bridges which, patched up, are still in use today over the big rivers. The Romans, however, did not merely build works of strategic importance. They went further and harnessed water for peaceful and progressive purposes. They built mills like those at Khuzestan, which are still in use today. And they built dams which turned the desert into the granary of the Middle East. The long Arab domination brought no improvements. The villages and towns came back to the riverbanks, and of the control of the waters nothing remained except for the traces left by the Romans. Even today, the siting of the principal inhabited centers is dependent upon the river system. Although the Arab civilization reached splendid heights, the extremely refined architecture and the beautiful polychrome domes and minarets cannot mask the fact that the farmer has remained backward, parched, and forced all his life to feverishly pursue a drop of water and a blade of grass. Something new is happening. The age-long silence has been broken by new voices, the voices of men at work. They ring across the arid plain burnt by the ever-present sun, echo in the rugged gorges cut by the waters of the river Dez through centuries, and penetrate the deep pits whose walls are covered with the etchings of time. In order to harness the waters for the irrigation of about 4,460,000 acres of arable land and to supply a valuable source of energy, the Dez project, which provides for the construction of the highest dam in the Middle and Far East, was born. The plan for the hydroelectric station on the river Dez was made by the plan organization of the Iranian government on a project furnished by the Development and Resource Corporation of New York, which availed itself of the collaboration of the Electro-Consult of Milan for the design of the dam. As a result of a competition in which the world's greatest construction companies took part, the plan organization awarded the undertaking to the Imprese Girola Lodigiani Group of Milan. Work began in December 1959 with the preliminary tasks, the laying out of the job site, building of roads, tunnels, dwellings, and cableways. The great distance from supply centers, the nature of the surrounding country, and the difficult living conditions made the phase of preparation particularly arduous and important, especially because of the necessity of moving an enormous quantity of material and equipment to the site. The entry to the job site and the gorge was the first big obstacle to be overcome. Whilst it was relatively easy to make a road to the edge of the plateau, this was not the case with the gorge. Its geological conformation and its walls, which rise almost vertically from the river, made the only possible way down to the bottom, where the dam was to be built, a tunnel 6 kilometers long with a section of 35 square meters which descends in helical curves on the right side of the gorge. In order to keep the job site free of water, the river had to be diverted through a tunnel which carried the waters of the Dez to a point below that at which the dam was to be built. Whilst experts with excavators, dumpers, bulldozers and rock drills start on the job of building the dam, on the edge of the plateau, a village rises quickly. A village with dwellings suitable for housing as comfortably as possible in the torrid desert climate, a community of 500 Italians who will remain there for 3 years. Under construction at the same time as the dwellings and the job office are the technical and administrative offices, a modern thermoelectric power station of 9,000 horsepower to produce the energy necessary for the job and for the life of the village. A mechanic shop, a rationally equipped hospital ready for all emergencies and staffed by Italian doctors. With Italian teachers for children from the second elementary class up to the second class of high school. And the Church of Santa Barbara, all built by the company. Other services for the well-being of the community were swimming pools, areas for sports and games, and open-air cinemas, and various messes with Italian cooks and rations which provided, even in these latitudes, nourishment suited to the Italian palate. Excavations for the dam were begun in September 1960 and were carried on under extremely difficult conditions, reaching the river bottom in August 1961. The laying of the foundations was then begun, whilst work on the upper parts of the excavations was completed, and more than 700,000 cubic meters of rock were taken from the diggings. Aggregates for the concrete were taken from an alluvial deposit at the foot of the plateau, 25 kilometers from the job site. Special screening trucks had to be used in order to eliminate material inferior to 19 millimeters as required by the technical exigencies. Production was about 2,200 cubic meters per day for a total of about 1 million cubic meters extracted. From the excavations was dumped in a natural pit on the plateau, from which it was later fed to mixers through a man-made shaft. The cement, brought from 250 kilometers away, arrived in special wagons at the nearby railroad station of Andy Mesh. Here it was unloaded into special trailers which carried it to the silos. From the silos, the cement fell by gravity to an intermediate silo, from which it was then pumped to the batching plant. The rubble from the shaft reached the washing and screening tower and was then carried to the silos, from where it passed through the coaling station and went on to the batching plant. The sand was produced on the plant. let us follow the same process on the plant itself. Cement in tubes drops down about 200 meters and reaches the intermediate silo. The rubble taken from the shaft is washed and screened and divided into 4 sizes, partially crushed and carried by the conveyor belt to the corresponding silos. A conveyor belt in a tunnel carries the aggregates to the cooling silos, where they remain in refrigerated water at 2 degrees centigrade, cooled by a refrigerator in a cave with a cooling power of 4,450,000 refrigeration units per hour. The sand is produced by 4 rod mills which crush the excess aggregates of various types. By means of Linatex pumps, the mixture of sand and water is transferred to the centrifugal screeners and pre-thickeners, and thence to the recuperators. From these, a conveyor belt carries the 2 types of sand to their respective silos. During the construction of the plant, a joint in the rock was found involving a mass of more than 25,000 cubic meters, which threatened the whole zone. It was necessary to bolt the rock with 550 rods more than 20 meters long and build supporting pillars of concrete up to 26 meters high. Having eliminated the threat of a rock slide, the production of concrete by the batching plant was begun. Automatic control of the tower and the cooling system ensured that a constant and precise proportioning of aggregates and cement with a maximum tolerance of 1% was maintained. The production of concrete was uninterrupted from October 1961 to December 1962 and reached a maximum production level of more than 3,000 cubic meters per day. During this period, the first buckets arrived at the base of the dam to begin the pouring of the foundation blocks. From that date, the 2 principal cableways transported without a break, the buckets weighing 18 tons each. The vibration of the concrete was begun. Day by day, with difficulty but with ever-increasing speed, the dam rises and begins to take on its characteristic form. meantime, the portals of the spillways on the left bank begin to take shape. The excavation for the outlet of the spillway for the first time in world history is carried on at full section of a tunnel 15.60 meters in diameter using a jumbo rig carrying 14 rock drills and designed and built on the job site. When the dam reached a height of 225 meters, the irrigation conduits were installed. The first prefabricated element in ferroconcrete weighing 19 tons for the construction of a spacious platform for the control of the irrigation conduits is lowered into place. The dam is almost at the level of the crest. The guides for the intake sluice gates are poured. Spillway sluice gates are installed. Inside, the covering of the inclined plane of the surface outlets by means of a mobile molding box weighing 63 tons, equipped with hydraulic jacks for its transfer and radial movements and 2 big safety winches, is going on. The mouths of the spillways appear in their finished state. The transformers, weighing 96 tons each, are brought by special trailer from the port of Khorramshahr on the Persian Gulf, 400 kilometers away. Through Through the long tunnel, they reach the transformer area where they are installed. The power station itself is housed in a man-made cave almost as big as the main nave of Milan Cathedral, and the assembly of the turbines and generators is in progress. Work on the primary substation is in the final phases. Whilst on the plateau, the pylons for the high-tension cables are being erected. From the transformers, the energy produced by the tamed waters of the River Dez will reach the plateau substation by means of a line from the generators. From here, a network at 132,000 volts, which covers the whole of Khuzestan through various substations, will carry the current even as far as the Persian Gulf. In November 1962, the deviation tunnel is closed and the flooding of the dam is begun. Work on the dam is about to reach its close. The last finishing touches are made, and soon nature will come into her own again. No longer an undisputed mistress, but subject to the commands of man for the future well-being of a region as large as 1/3 of the Italian peninsula. On March the 14th, 1963, in the presence of the diplomatic corps accredited to Tehran, His Imperial Majesty Mohammad Reza Pahlavi officially opened the dam on the River Dez. From that moment, the dam takes the name of His Majesty the Shah. Together with the representatives of the Plan Organization and the delegates of the Development and Resource Corporation, His Imperial Majesty was particularly careful to express his satisfaction to the representatives of the Imprese Italiane all'estero, Girola, Lodigiani, and KGT. the transformer area, the Italian ambassador, Mario Pinna Gaboni, and the general manager of the associated companies, Sergio Morpurgo, presented His Imperial Majesty with a commemorative gold medal. Two workmen, on behalf of their Italian and Iranian colleagues, offered the Shah a plaque made from a sample of the concrete from the dam, a symbol of the brotherhood of the two peoples. Where there was once an arid, desolate valley, there is now a lake more than 60 kilometers long, with a capacity of 3 billion cubic meters of water, whose beneficial effects will in time modify even the climatic conditions of the area. The dam is a thin arc with a double curve and is 203.5 meters high and is the 6th highest dam in the world and the highest in the Middle East. For the dam itself, 460,000 cubic meters of concrete were used and a volume of 403,000 cubic meters of rock and rubble were excavated, whilst the overall quantity for all installations called for the removal of about 1 million cubic meters of rock and rubble. 100 Italian technicians and 426 workmen, together with 2,000 Iranian laborers recruited from all over the country, achieved a total of 14 million man-hours on the job. Calm returns to the plateau and to the walls of the gorge, and men's voices are stilled. In a silence which is no longer deathly but peaceful, the lake lies still under the sun. Witness to a new achievement of civilization.